Alright, today I'm going to talk to you about graphing lines. This is going to be in sections 3.1 and 3.2. The first method we're going to discuss is graphing lines using a table of values. The second method that we will talk will be using the x and y intercepts, and the third method will be slope-intercept form. Do keep in mind that when we graph lines, we need 2 points. So we're going to be looking for 2 points when we're graphing lines. Using a table of values, what we do is we actually get to choose a number that we can substitute into either x, in this particular case right here, or into y. Notice that what we're going to do is graph the line 3x plus 4y equal to 10 by determining 2 ordered pairs or 2 points. In this particular ordered pair, we want to know when x is 2, meaning well, we have our values here on the x-axis. When we're here at x equal 2, where is our y value going to be located? Are we going to go up? Are we going to go down? Or will we stay where we are? Well, in order to do that, we're going to take 2 and we are going to substitute it into the place of x here in the equation. So we're going to have 3 times 2 plus 4y equal to 10. And using steps to solving an equation, we'll solve this to get 6 plus 4y equal to 10. We'll subtract 6. That'll give us 4y equal to 4. Divide by 4. That gives us a y coordinate of 1. So what that means is when we're here at x equal 2, our y value is here at 1. That's our first ordered pair that we can use in order to graph this line. Now we're going to come over here for our second point, or second ordered pair. Notice now we have 4 in the place of the y value. So what we want to determine is, okay, where would that be as far as our x coordinate is going to go? So what we'll do is take 4, we'll substitute it in the place of y this time. So we're going to have 3x plus 4 times 4 equal to 10. And we'll use steps to solving equations again. We'll subtract 16. That's going to give us 3x equal to a negative 6. Divide by 3. We get an x coordinate of negative 2. So here we have our second ordered pair. So that means when x is at negative 2, our y value will be up 4, 1, 2, 3, 4. Now that you have the 2 points, we're going to connect those 2 points, and that's the graph of our line. So the graph of 3x plus 4y equal to 10 is this line right here. Okay, note that a line can be graphed using any 2 ordered pairs. Now keep in mind these 2 ordered pairs are not the only set of points on the line. It's just the 2 that we were able to find for this particular example. Alright, well let's try one more example using an XY chart. This time I'll show you the chart, and the chart is pretty much the same way as how we labeled the points. But this time, instead of putting something in the x and something in the y, I'm just going to stick with plugging in values here for x. 0 is always a good number to use whenever we are trying to find a set of ordered pairs. We could also use any other number, 1, 2, 3. You can use negative numbers, whichever you choose would be the best. So let's try 5 in the place of x. So what we'll do is come over here, we'll take the equation 4x minus 5y equal to 20. First one we'll substitute 0 in the place of x. That's going to give us negative 5y equal to 20. We'll divide by negative 5. Y will be negative 4. So that's one ordered pair there, so that's the point 0. So when we're at the x value 0, we're going to go down negative 4. Okay, so now when x is over here at 5, 1, 2, 3, 4, 5, are we going to go up, are we going to go down, or are we going to stay where we are? So we'll substitute 5 in the place of x. That's going to be 20 minus 5y equal to 20. We'll subtract 20. That's going to give us a negative 5y equal to 0 divided by negative 5. We'll get y equal to 0. So when x is at 5, 1, 2, 3, 4, 5, we actually don't move. We stay where we are because this is 0. We can connect those 2 points, and there is the graph of the equation 4x minus 5y equal to 20. Alright, the second way we can graph lines is using specific points, the x and y intercepts. X and y intercept, the x-intercept means that where the line crosses the x-axis. Okay, the y-intercept is where the line is going to cross the y-axis. Something to keep in mind with these 2 points is to know that for each coordinate, each point, one of the coordinates is going to be 0. Alright, if it's the x-intercept here, that means that the y-coordinate will always be 0. If it's the y-intercept here on the y-axis, that means that the x-coordinate will be 0. So what we'll do, something I tell students is to think 0 when you hear of an intercept, meaning one of the coordinates will be 0. Okay, for these two, notice we have the 2 points, and in the place of the x-coordinate we have 0 for this point. In the place of the y-coordinate we have 0. That makes this point with 0 in the x, that makes this the y-intercept. With 0 in the y, that makes this the x-intercept. So we'll just take this number, we'll substitute 0 in the place of x. That's going to give us a negative 5y equal to 10, divided by negative 5, y equals a negative 2. Okay, so that's going to be our y-intercept here at 0, negative 2. Then we're going to come over here and now substitute 0 in the place of y because it's our y-coordinate. That's going to give us 2x equal to 10. We divide by 2, x equals 5. So that gives us the point 5, 0. Now, that's 2 distinct points, 2 points we can graph our line. So we'll graph the line here. So that's the graph of 2x minus 5y equal to 10. Alright, well that's one more method that we can use to graph line is to graph lines using slope-intercept form. You will need to know this form, y equals mx plus b, where m is the slope of the line. Remember that slope refers to the slant, the incline, the steepness of a line. Slope can either be positive, negative, we can have a 0 slope, or the slope can be undefined. The b part, this particular number here, refers to the y-intercept. Okay, it's where it's going to cross the y-axis. So for us to graph a line in slope-intercept form, remember we need 2 points. Notice though, between the 2 pieces of information, this, the intercept, is the only point that we know. So what we do, find our intercept, we plot that intercept. Now what we do from that point is from that point take our slope. Remember, slope is rise over run. Remember, you rise either up or down. The run, we go left or right, depending on what our numbers here are for rise over run. Find the slope, rise over run, and that will help us find our second point. So this example, it's in slope-intercept form. Here we have negative 2, that is going to be our intercept. That's the point 0, negative 2. Here our slope is 3 over 4, that's the m. Remember that this refers to rise over run. Because 3 is positive, we're going to rise up. And because 4 is positive, we're going to run to the right. So let's first plot the point 0, -2, which is our intercept. From the point, then we're going to go up 3, over to the right, 1, 2, 3, 4. That's the second point on the line. There's 2 points. There's the graph of our line. Okay? One more example here. What if we have the equation of a line, but it's in standard form? Well, if we want to graph using slope-intercept form, we'll just take standard form and we will solve and put it in slope-intercept form. So that means we'll solve for y. To solve for y, we'll move the x over to the right. By doing the opposite, that's going to give us a -5y equal to -2x plus 10. We'll divide by -5 for each of the terms. That's going to give us our slope-intercept form of y equals 2 negatives is positive, 2 over 5x, and then 10 divided by -5 is a -2. Here we have our intercept at 0, -2. Our slope here at 2 over 5. So we rise over run. So we're going to plot the intercept first here at -2. And then we're going to go up to the right, 1, 2, 3, 4, 5. Now notice the whole slope was positive, but here, if we had left it in this form, notice that it was -2 over a -5. We could, because both of these are negative, it still makes the whole thing positive. So if I wanted another point here, I could actually from the intercept go down to and then to the left, 1, 2, 3, 4, 5. But notice if we did that, the points still line up so that we can connect those points to still graph our line.